So we're going to talk about direct and indirect, or direct and inverse, and joint, and all these other different ways for things to vary, okay? And the first one I want to talk about is direct. And guys, naturally you're going to want to use proportion. I naturally want to use proportion, because proportions work for direct. Now, they get really messy when you try to do indirect and joint and inversely versus jointly and combination. Proportions get messy. So I'm going to teach you a way that works for everything, and then you don't have to worry about it, okay? The first thing I'm just going to talk about is something called a direct variation. And basically, if you think about something, and I'm just going to write this down to let you kind of look at it for a second. If I tell you something is directly related, they're going to be related in a way. For example, I'm going to tell you k equals 2. In other words, the relationship is 2, right? Now, when things are directly related, as one thing goes up, the other one also goes up, okay? They both increase. And what I mean by that is this. If I tell you y equals your constant value times your x, okay? Because I'm multiplying, then what happens here is, for example, if I say that, then I'm going to say, okay, y equals, what's my constant? 2, right? So if you take this, I'm going to do this several times here just to show you something. Okay, now, if x is 1 here, if I put in, if my constant is 2, if x is 1, what's y? 2 times 1 is 2. Then if I change it, if I make x worth 2, y is how much? Becomes 4. If I make x worth 3, then y is worth 6. So as x gets bigger, 1, 2, 3, y gets bigger, 2, 4, 6, right? That is what they call a direct relationship. Now what's cool about this is because I know the constant is 2, I could come down here and say, okay, y equals 2, and what if I said that x was 100? What would y be? 200, okay? By knowing the constant, by knowing how x and y are related, it makes it very easy. Okay, so what we're going to do in every problem is we're going to find how x and y are related. And then we can solve for 100, we can solve for 5, we can solve for 1,000, we can solve for anything we want if we know how x and y are related. And that's what they call k for the constant in every kind. All right, so let me show you what this is. So here's your notes. It says direct variation. It's one special type of a linear function, okay? And it's a situation that translates to an equation of the form y equals kx. So in other words, y varies directly as x. And the way it's written is this way. Y, okay, varies directly means we're going to multiply whatever the constant is times your x. And here's the proportion method, which I'm not going to look at today, but you're welcome to use it if you'd like. Okay? So if k is positive, if the value of y increases as the value of x increases. Isn't that what we just figured out? As x gets bigger, y gets bigger. As x gets smaller, y gets smaller. It's a direct variation. So we're going to actually solve some problems like it. I'll give you a second to read number 1. So the actual question is, find time if how much she makes is $178. So in other words, if I'm going to make $178, how long do I have to work for? That's what it's asking, okay? But before that, it's going to tell you a couple things to help you find the answer, okay? And always in all of these direct variations, your key to it is to find, remember earlier we knew k was 2, right? I can find anything I want as long as you know the constant, the relationship between the two things. So step 1 in all these problems is to find the relationship, find the constant. Okay, it's called a constant. It's just, to me, easier to think about as a relationship between two numbers. Okay, in this problem, the relationship was twice as big, right? Okay, so on here, it tells us that y or d varies directly as time. So instead of y equals kx, we're going to use, okay, D equals K what? T. Okay, normally it's Y equals KX. That's the kind of the idea behind it. Okay, but this time it says the dollar varies directly with the time. So I'm going to say D varies directly, that means multiply, with time. So that's my formula. Then it's going to give us some information. It's going to tell us, okay, I know that she makes $116 if she works 15 hours. Okay, so remember I told you the step one is to find K every time. So I'm going to substitute those into my formula. So D is 116.25. I don't know the constant. In other words, I don't know how much she's making per hour. Okay, but I do know she's going to work for 15 hours. And 15 hours pays her $116. So by finding K, we find the relationship between time and money. So if you divide both sides by 15, you get $7.75. She's not making very much, is she? Okay, so she's making $7.75 an hour. Now knowing that, you can find anything. I can find out how much she's gonna make if she works 5 hours. I can find out if she makes $150, how many hours she's gonna work. Anything I want. Because I now know the constant. The relationship between everything is $7.75. So let's see what they're asking. They're asking me to find time if the total amount is 178. So I'm going to go back and take the same equation, D equals KT. This time, I know D is 178. I know my constant is 775, and I don't know my time. So divide both sides by 775, and in order to make the $178, she has to work 23 hours. If there's a unit of measure, be sure to use it. Okay, the next one. The perimeter, in other words, the outside, right, of a regular dodecagon. Does anybody know how many sides a dodecagon has? I heard it, what? 12, yeah. The perimeter of a regular dodecagon varies directly, okay? That means we're going to use this formula, y equals kx. Agree? That's the varies directly formula. So the perimeter varies directly with the side length. That makes sense, right? The longer the side, the bigger the perimeter. Okay? So, but we're not using y and x, we're using perimeter and side. So I'm going to change this to p equals ks. This is just kind of my starting point. And my step one is always to find the relationship between the two things. Find the relationship between the perimeter and the sides. And it's going to tell us the perimeter is 18 when the sides are 1.5. That's going to help you find K. So the perimeter is 18. We don't know the constant. We don't know the relationship between them. So we're going to find it by taking 18 divided by 1.5. So the relationship is 12, which is what we just decided, right? How many sides are there? 12. Okay. Now we know K. Then it says, well, okay, find how many sides there are if the perimeter is 75. Find, not how many sides, I'm sorry, find the side length if the perimeter is 75. So 75 equals 12 times S. So what are you going to do to each? What are you going to do? Divide by 12, which gives you 6.25. Okay? All right, now we're going to move on. Now we've got direct variation. What about inverse or indirect? What do you think that means? It says that a relationship between two variables such that, look, it's different. It's not multiplication anymore. It's what? It's division. Okay? Look what happens when you divide instead. So there was my direct, and here's my indirect or inverse. okay? In other words, instead of times, I'm gonna say y equals k divided by x, right? Okay, and let's say k, for simplicity, equals 1 this time. K is 1, my constant is 1. So I'm gonna have y equals 1 divided by something, and y equals, we're gonna try a couple things here. All right, now, so if I make x 1, 1 divided by 1 gives me an output of 1. If I make x 2, 1 divided by 2 is how much? 0.5. If I make x 3, 1 divided by 3 is 0.3. So as x is getting bigger, 1, 2, 3, what's happening to y? 1, 0.5, 0.3, what's happening? It's getting what? Smaller, yeah. So indirect means as x gets bigger, y gets smaller, because you're dividing, right? Don't numbers get smaller when you divide? Unless it's decimals, but just the idea, right? Well, if you have this situation, can somebody tell me what x is not allowed to be? Right. What does the graph look like of this? You have a variable in the denominator. Does anybody remember what it looks like? Right? Because look, as you're going here, I'm not allowed to touch x equals 0, am I? So I can get closer and closer to it, but I can't actually hop over. I can get closer and closer, but I can't actually hop over. Okay. So now that we kind of understand that, then this is an inverse or indirect variation. Here's your formula. In this situation, one quality goes up while the other quality goes down, right? Now the idea is exactly the same. You have to find k. You've got to find the relationship between the two things. So it says y varies inversely as x. Inversely means divide. So y equals k divided by x. And then it's going to give you some information to help you find k first, so that you can find the relationship. Once you find the relationship, you can find anything you want. The information it told us is it gave us information about y and x. It said 4 equals k divided by 12. So what's k? K is 48. Okay, now that we know that, we can find anything we want. Okay, and here's the question it asks us. Find y if x is 5. Well, now that I know k, I can do it. My formula was y equals k divided by x because it's inverse or indirect. Okay? And then so then that means I'm going to say y equals 48 divided by 5. So y equals 9.6. All right, now go to the next one, number 2. The time it takes for a group of volunteers to construct a house varies inversely, means we're going to divide, as a number of volunteers. In other words, how long it takes is going to go up if the volunteer numbers go down. Isn't that correct? Okay? How long it takes is going to go down if the number of volunteers I have goes up. So to find that value, it's a division. Okay, so if my formula starts off as y equals k over x, but we're not using y and x, we're using actual variables of things, right? So we're saying time varies inversely with volunteers. So the way you write that is time varies inversely with volunteers. The same way, y varies inversely with x. Time varies inversely with volunteers. You see how I wrote it? Okay, and then it's going to give us information to find the relationship between the two first, always, so we can find k. 20 volunteers can build a house, dang, in 62 hours? Yeah, that's pretty cool. Okay, so let's see what happens. 20 volunteers, so let's find k. 62.5 equals k divided by 20. So my constant would be 1250. Now that I know the relationship between volunteers and time, I'm gonna answer my question now. How many volunteers are gonna need to build a house in 50 hours? Okay. So 50 hours equals K divided by, no, we know K, I'm sorry. $12.50 divided by K. V. Right, some kids are having trouble solving this. I like to think about flipping them both, but V's in the denominator. So you're going to have to multiply both sides by V to get rid of it. So really I have 50V equals 1250. Which means V is 1250 divided by 50. So V is 25 volunteers. Got it? Okay. The next one. Combined variation. Okay, that means you're gonna, this one's very real life. Think about something, a situation in life. Is there only gonna be one factor? Like, for example, that house building. Volunteers are the only thing that's gonna affect how long it takes, right? What about the weather? Okay, so things can be a direct variation and an indirect variation. That's just real life. And that's what this is talking about, okay? So it's saying, all right, combined variation is a relationship that contains both direct and inverse. That's more real, okay? So let's try it. Right, remember, direct means multiply, indirect means divide. The volume of gas varies inversely. So volume, if I vary inversely, I'm going to do K divided by inversely as the pressure. So volume varies inversely with the pressure. So V equals K over P, right? Then it says, and directly as the temperature. When you have a direct variation, you multiply it by K, right? So where's the T need to go if you're going to multiply it, top or bottom? Good, top. You're multiplying by K. Okay, now then, let's find the relationship between time and pressure and volume and all that other stuff. A certain gas has a volume of 10, so there's my 10, a temperature of 300 Kelvin. We obviously are not going to know K, that's the point right now.
Wait. But there's a conversion between Celsius is like 273. Oh, is it asking?
Well, it's just asking for, it's not asking for to convert.
Oh, okay.
And then the pressure of 1.5 atmosphere. So now then, we're going to solve for K, so multiply and divide. So K is 0.05. And then the question then, now that we found the relationship between everything, okay? The question is, if the gas is compressed at a volume and heated to 350, what will the new pressure be? It's asking for pressure, it's asking for P. So if the gas is compressed to a volume of 7.5, it's heated to 350, so the temperature is 350. We know the constant is 0.05. We do not know the pressure. Right? So you're gonna multiply both sides by P. So I've got 7.5 P equals 350 times 0.05, which is 17.5. Divide by 7.5 on both sides, and I got 2.3 ATMs. Ready to go with that? Okay, flip it over to the back. Here's just a picture of what we already talked about. Okay? Look at the first one, this one right here. This picture says that in a direct variation, y varies directly as x. and the graph of a direct variation is a straight line. That makes sense, right? Just like the graph, the table we did. Okay, it goes up. As one goes up, the other one goes up. Right? Now look over here at this one. This is what a graph would look like if we vary inversely. Right? Okay, if you have a variable in the denominator, you're not allowed to be 0, so it makes your graph look really weird. Okay? Now, let's ask a question then of this. Determine if each represents direct or inverse. So what I like to say for these kind of problems is I ask myself every time, as the first thing goes up, what happens to the other? Okay? If you'll just say that to yourself every time, these are easy. Number 1, the number of pancakes made and the amount of pancake mix used. So I ask myself, if the number of pancakes made goes up, what happens to the amount of pancake mix used? Is more going to get used? Yeah, they're both going to go up, aren't they? So the answer to this one then would be direct. Because they both went up. Number 2, the price of milk and the number of gallons you can buy for $20. So as the price of milk goes up, what happens to how much you can buy for $20? What is it going to do? It's going to go down, right? As the price of milk goes up, you can get less and less, right, for $20. So one goes up and one goes down, so that's inverse. The next one, I'll let you read it. Okay, what do you think? The outside temperature of the winter goes, okay, so if the outside temperature goes up, are you gonna need more heat or less heat? Wait. So as it gets warmer outside, you're gonna need less heat, aren't you? Okay, so that's gonna be what?
Inverse.
Inverse again. Try number 4, a child's age and its height. As a child's age gets older, what happens to his height? Hopefully.
Direct.
Unlike my son. Okay, so it's gonna be direct. Right, the next one, number 5. The number of apples purchased and the total cost, what's that gonna be?
Direct.
Direct, okay, so you've got it. All right, so now we have one last type, and it's called joint variation. Joint variation varies jointly as x and z, okay? And that, guys, is just all multiplication. It's like direct, okay? So instead of doing kx, it's kxz. In other words, two things are varying together. So if you look at this one, if y varies jointly as x and z, so it was written like this. Okay, and then it's going to give you information to find the constant. It's going to give you all 3 variables except k, so you can find k. So 10 equals k times 2 times 4. So k ends up being 1.25. Now that you found k, you can solve for the question. It says find y then, if I only know x and z. So y is going to be 1.25 times 4 times 3. So y is 15. Okay, we're going to skip number 2 and go to 3. 3 will be the last one for today. Try number 3. It varies jointly. The cost of hiring a contractor to build a patio, so the cost varies, so there's my K, jointly as the area in square foot of the patio and the price. That makes sense. Both of those make it go up, right? How big it is and the cost of the materials. Both those are going to drive something up. So the area and the cost. Oh, wait. Price, they used it as P, I'm sorry. Thank you. So originally, they give us all the variables 28, 32, K, 80, and 295 per square foot. So K, the relationship between all of it is 12. Now I'm gonna say, well, find me the price per square foot. Then if the cost is $43.68, my constant is 12, my area is 112, and I'm looking for P. The price per square foot would be $325.